So, welcome to our first lecture in calculus. So today we're going to be talking about some of the fundamental building blocks of calculus. By the way, you'll hear my chair squeaking throughout the videos. I hope you don't mind. I need a new chair. Okay. I'll probably get one after things settle down. Okay. So, what is calculus? We talked about that in the video before, and calculus is the study of how things move. And so, or we could just say, instead of move, we could use the word change. Okay, and I also want to be more specific about things, because the things we're going to be talking about are actually functions. Okay, and there's a reason for that. Let's take a look at the definition of a function and see why we're using them. So definition. A function, sometimes we label it F, is a rule. It's a rule or an association that associates, I guess I'm repeating myself there, associates one number that's called a number from the domain. It's chosen from the domain, of the function to another number. And that is from the codomain. Actually, we're going to be a little bit sloppy and call this the range, but there is a difference between the two. Okay. The range is actually the set of all outputs from the function that are hit by all the inputs. And so we'll see a difference between those in just a sec. So there's something else that's missing here, and that is when I say that we're outputting numbers, we can only output to another unique number. So in other words, if I put the number 1 into my function, a specific number, say 3, must come out, but I can't put in 1 and get out like a 3 and a 5, right? It's only got to be a single number, and that's what makes a function. And so, in fact, you might remember that graphically, we usually put our x down here and our y up here, and so the x's represent the domain, and the y's represent the codomain. And then for each point on here, you can think of it as defining a relationship, right, between the domain and the range. And so the idea here is that if I take any vertical line, so if I take all possible associations with a particular value of x, how many times can this curve intersect the line and still be a function? It can only intersect the curve once, because if the curve had come back around on itself like this, right, then at this particular x you would actually have two different y values. Oh, I got a colorful thing here. Okay. So that would not be a function. And so functions, let's see if I can erase that. Functions then can only intersect any vertical line at most once. Okay, of course it might not intersect at all, right? In that case we would say that this point of x is not in the domain. And in fact, if this is my entire curve, you can see here that this value of y is not in the range, or sorry, not in the codomain. Sorry, let me say that again. The domain is the set of all x that we're using from the horizontal axis here. The codomain is everything along the y-axis, so everything here. But the range of the function, the range, is only the set of y's that are hit. So in this particular example, that's only these y's from here up to here, right? So from here up to here, these are all the y's that are hit. So we would say that this is the range of the function. Okay. So what does this mean algebraically if we were to try an algebraic version of this? So a common question that might be asked is something like this. Let f of x be equal to the square root of 3 plus x minus the square root of 2 minus x. And so we would want to find the domain. And so this question is really saying find, whoops, let's see if I can spell, find all x values for which f is defined. Okay, and so what do I mean by that? Well, for example, suppose that x was equal to minus 5. Well, here, this first, if I tried to put in minus 5 for x, then this first square root would be the square root of negative 2. And we're assuming, right, that our outputs are real numbers and not complex. And so that x would not make our f defined. And so for f to be defined, we would need two things to be true. We need 3 plus x to be greater than or equal to 0, and we need 2 minus x to be greater than or equal to 0. Okay, so in this case, we need x to be greater than or equal to minus 3, and x is less than or equal to 2. Okay, and so on a number line, right, that means you're between 2 and minus 3, including 2 and minus 3. So x can be between minus 3 and 2. And so let me just briefly pause here for a second to talk about interval notation. So if I have a single interval like this, let's go ahead and say that I'm excluding a and including b. Then I want to write that in interval notation as x is greater than a and less than or equal to b. Okay, on the other hand, if I take, let's say this interval and this interval, right, then I want to, my interval notation would be that x is less than a and, or, I gotta have an or because they can't be both, or x is greater than b. It can be less than or equal to a. Good. So what I mean by that is if you have a broken interval, you want broken notation. If you have a single interval, use a single notation. And remember that this should be the largest number and the smallest number. I see a lot of people, I don't see a lot of people, but some people try to get kind of creative with this interval notation. We want to be able to figure out what the interval is just by looking at what the notation is. So again, that means a single piece of notation should be a single interval, and broken. Good. All right. Now, I want to talk about one more thing here for general functions, and that is function notation. Function notation. When I wrote the rule f of x equals the square root of 3 plus x minus the square root of 2 minus x. So we interpret that as saying if I want to compute like f of 1, right, I would replace the x's in here by 1. And so that would be the square root of 3 plus 1 minus the square root of 2 minus 1. And then I would continue. Right, so similarly f of 0 would be the square root of 3 plus 0 minus 2 minus 0. And then I would continue that computation. Okay, so similarly, if I give you some weird notation, like write an expression for f of a plus h minus f of a, how would we do that if this is my f of x? Well, we would write our f of a is similar to this. That would be the square root of 3 plus a minus the square root of 2 minus a. And then f of a plus h would just be the square root Are you getting the idea? 3 plus a plus h. Notice that this whole thing is being replaced. So I know some people will put the h, like add on the h outside, but that would be incorrect, right? And so the a, well, so this would be 2 minus a plus h as a quantity. Good. All right. And so we would just subtract those then to get our expression. So that would be square root of 3 plus a plus h minus the square root of 2 minus a minus h minus square root of 3 plus a minus the square root of 2 minus a. Good. This would be my final answer then. All right. I'm going to pause there since we're out of time for now, and we'll continue this discussion next time.